So, hey everyone, my name is Patryk, this is Adam. I have my notes here, just so you don't think I'm scrolling Twitter while presenting. We're gonna talk a bit about hosting, both on serverless platforms like Vercel, and doing the setup yourself, and what are the differences, and we're gonna show you a pretty cool setup. Thanks. We're gonna show you a pretty cool setup, in our opinions. So maybe before we begin, has anyone here heard of Nix? N-I-X. Ah, nice, nice. We have a few people, nice. Okay, so let's get started. Say you want to deploy an web app today. Well, it may be your first choice to go to one of these providers. Vercel and Netlify for the front end, and Firebase and Supabase for the backend, if you need one, if it's not just a landing page. That's cool. There are many advantages to doing it this way. For example, it's very fast. You can just link your GitHub repo and see the projects online. So you can send it to people, get your first customers. It's easy and fast. Second of all, you don't have to have any prior knowledge, and you don't have to spend time learning stuff that you may not want to learn or never need again, just to set up a server. Third of all, the iterations are quick. I mean, you just git push and see the changes. It doesn't get really better than that. And lastly, the pay-as-you-go pricing model can be really beneficial. This comes with many limitations, though. For example, the unpredictable costs that come with a pay-as-you-go pricing model. That combined with it's not always being clear how the price is calculated. We know that it's compute and some bandwidth, but how exactly, we're not sure. And the pricing can change rapidly. If you're not staying on top of it, you can get surprised with a huge bill. So another thing is how limited those platforms are. Say you want to use a database that's really good for something or any software at all. You either have to wait for your provider of choice, like Vercel, to integrate it and adopt it into their platform and let you use it, essentially. Or you have to rent a server and host it yourself, in which case you're back to us. Or you have to find another serverless provider that offers it. And this way you can end up with this web of third-party dependencies, like, for example, Vercel for your front end, Firebase for your backends and database, and something for auth as well. Everything has a different pricing. Maybe you use a different tier. It can just become a mess. So a good example of that, ClickHouse. At Diallo, we use ClickHouse. It just lets us scan through lots of data very fast. And they have a serverless model. So let's check it out. We'll just go with the basic tier. You get 1 terabyte of storage. And here we have a pricing calculator. So yeah, it's a bit hard to see. So maybe I'll say we chose 1 terabyte and the cheapest compute, which is 8 gigs of RAM and 2 cores. And it's always on. And that comes out to $162 a month for your database. So let's compare that to bare metal. This is a screenshot from Hetzner. They rent servers. And let's, to match Vercel's compute, let's get the second cheapest option at $759 a month. That has 4 cores and 8 gigs of RAM. But we still need the storage. So let's get 1 terabyte, just as we had on Vercel. And that comes out to about $50 a month. So putting that together, that comes to just shy of $60, and we have 2 cores to spare. Now, comparing that, it's hosting this ourselves saves us $100 each month. Not only that, on Hetzner, we get a server, so we can host our project there. And many others, in fact. 4 cores and 8 gigs of RAM is plenty. On ClickHouse, that's just the cost of storage. So why shouldn't we self-host? I mean, it's cheaper. It's we have more freedom. Why? What are the downsides? Well, they're right here. There's lots of stuff you have to do. A lot of stuff you have to remember and learn. So, for example, to get a basic app running, so first you have to make the app. Okay, it looks good on localhost, so you compile it or bundle it. You have to get it onto the server. Maybe you want to run it in the background, so you use systemd services. What's that? And you have to use their configuration language that's not used anywhere else. Same story with Nginx, configuration language that's not used anywhere else. Maybe you want to use Docker, Docker Swarm, Docker Compose. What are they? Which one should you use? It's a mess. But it doesn't have to be. What we're going to show you today is a setup that uses just 2 tools to manage everything. One of those tools is Nix, and the other is Kubernetes. But Kubernetes is really more of a platform where we will host our stuff. So really, we end up with just one tool, Nix. Everything from building our project through configuring the server to deploying can be done with Nix. So first, let's maybe check what it looks like to deploy Kubernetes without Nix. We'll be looking at K3s, which is a simplified Kubernetes distribution that handles some stuff for us out of the box. And the first thing you always do is look at the docs. OK, so here they lecture us about configuring a firewall, unless you use a different firewall, in which case you do that. Here they say we might need an external database if we want it to be production ready. I guess we do, but maybe we don't really want to do that. Here they just give us some shell scripts we have to run. Now, I'm not exactly a fan of running strange shell scripts I found on the internet, but it's K3s, so maybe we'll trust them. And oh my god, danger. Well, now I really don't want to use that. So why can't we just do something like that? Well, it turns out we can if we use NixOS. NixOS is a declarative and reproducible Linux distribution. What does that mean? That means we just describe the state of the machine that we want, and NixOS will handle the setup for us. So we can just write that we want the service K3s to be enabled, and Nix will do that. So what does that look like in practice? We have a demo here.
Mic holder.
This is a fresh NixOS VM.
I'm not just here for holding the mic. I will be talking.
We promise. This is a fresh NixOS VM. Basically, right after install, you'll get something like that. So let's just go into the directory in which NixOS is configured. And you can see we have 2 files here. The entirety of NixOS can be configured with just those 2 files, but the hardware configuration you see gets generated for us, and we never have to look at it. NixOS generates it when it's installed, and you never open that file. So really, we have just one file. That's the configuration.nix. So that's what it looks like. The only thing I have added here is some Git and an editor. It will look something like this right after you install. So let's do exactly what we saw on the slide. Oh yeah, I can see.
There's a we can't.
Something with the software we use for VMs, it doesn't let us, I think. Yeah. Unfortunately, I'm going to have to talk about what I'm doing. So right now I'm typing in the word services dot k3s.enable equals to true. Saving and exiting. And now we have to run one command. That's just to let NixOS know that something in the config has changed. And once we run it, Nix will evaluate the config, get everything we need and everything we want, set it up exactly how we told it to. In this case, we didn't tell much, so it's just going to provide some same defaults. And we should end up with K3s installed. So it's done. Let's check. The command doesn't matter, but you can see it's green. Green is good. It's enabled. It's running. But that's not the only cool thing we can do that Nix allows us to do through its declarative setup. We have made a blog for this presentation. This is just the GitHub repo for it. You can check it out. Oh, not my keyboard. At easybaremetal.com. If you're interested, there are some tutorials here, and it goes into much more. It goes much more in depth than we could have because of the length of this presentation. So for the repo here, let's just go into a directory in which I have the config. So let's check it out. This is a config on Git. That's a good point.
Right.
And so here is basically the same config. It just has a few more packages like Calce and Beatup. Just to confirm, we don't have them right now. It says command not found, if you can see, and the other one as well. So now we can run the same command we just ran before, but we can specify to Nix where it can find our config. And here we'll provide it a path to GitHub. And optionally, you can give it a directory. So now Nix, thanks. So now Nix will first go to GitHub, get the config, and then do the exact same thing. This is great if you want to, for some reason, change servers. So maybe let's say your server provider suddenly raised its prices by a lot, and you want to move. The only thing you have to do is get the config out of there and onto your new machine. So we didn't have those packages. You can still see at the top. Well, maybe you can't, but I promise you it's there. And if we run the same commands now, we have them. Same thing for the other one. It's there. OK.
All right, that's me now. Let me change it to the, where's the presentation thingy? All right, so that's nice. I am also not scrolling Twitter. I'm changing to my notes. So that's nice. We have, I should be in the camera, I guess. We have our Kubernetes installed, deployed to NixOS, and that was very easy, just one line. And to move on with this presentation, we want to do everything with Nix, not just deploying Kubernetes. So I guess we should kind of talk about what exactly happened there. Well, maybe not exactly what NixOS did, but how did all of this happen that we just declared something and it magically changed our environment. And well, NixOS is a Linux distribution based on Nix. And we will do everything with Nix, so let's talk about Nix. And Nix is a massive thing. I don't think I know everything about Nix, and I use it quite often. I don't know if anybody knows everything about Nix, but you might hear from tutorials and stuff that Nix is three things. It's package manager, programming language, and operating system that you just saw a second ago. And it's indeed those three things that are strongly connected with each other. But for now, I want you to think about Nix, especially for those who never heard of Nix, that it's a tool for creating declarative, deterministic software environments. So let's decode that with a simple statement, with a simple example. Say you're building a JS app, you have a project with some JS app, some front-end to bundle or anything, and let's inspect the like a stack of dependencies. So first you have your JS dependencies that are listed in package.json, and you have the log file from whatever package manager you're using. So that's great, we have a log file that's pretty consistent. So that's cool, but we need to run it with something. So say we use the Node.js runtime, but this also has some version. So I guess we're using NVM for that, for example, Node version manager. And we might also have some external dependencies that are needed either in the runtime or development time, some external binaries. So I guess we're using Homebrew for that on macOS or some other package manager on whatever OS you are developing on. We don't have a log file for those things, and we don't really know what version should we use exactly, and we need to like know in our head what version of Node to enable, I guess. So to know the version, I guess we is it changing? Oh, we need to look into our documentation or maybe call our friends if we have some. So let's look at what we do with Nix in this scenario. We have our JS dependencies, that's right. We have the log file, this is consistent. And everything else is basically done with those two files, and one of which is also a log file, but it's a Nix log file. And this is basically Nix, which is describe everything we want in our environment with the flag.nix file in the Nix language. And Nix will prepare that environment for us, and whether it's JS runtimes or some other external dependencies or environment variables, whatever we need, we can describe it in Nix to both build our application and develop it. And even if you have multiple projects or applications on your machine, or you're building multiple applications on one machine, those environments are totally isolated from each other. And this kind of looks like a Docker image, like an isolated environment with its own dependencies. And you can indeed build Docker images from those Nix environments, Nix declared environments. And this is definitely the Nix environment, the software environment that Nix creates is definitely not a Docker image, but because it's so deterministic, you can build Docker images with Nix. So just to see that in action, let's maybe take a look what a flake looks like. On the right, there's some Nix language, but it's basically like a JSON with functions. And the most important parts are the first inputs, which are just really imports of repositories where you fetch your packages from. Then you get some outputs, which is actually a function, which this colon, a little colon there means a function. And basically on the left you have the argument, on the right you have the return values. So on the left we have all of the packages that we said in the inputs that we want to have, and what do we return. And this is probably the most important part, that we have packages, and there you list all of the packages and apps you're working on. So for example, you describe to bundle some front-end from your source, and you're describing the whole app, and then you trigger it with Nix build, which results in some directory. It just gives you some directory with the builded stuff, or a file if it's a file. It depends on you. And then we got dev shells, which lets us describe a development environment that we want to have for developing those projects. So it's pretty common to use the same packages that you use in the packages that in the app you described in the dev shell. And you trigger dev shell with Nix developed, and this opens up a new batch with all of the dependencies in your environment. But let me just show you that in action. I think it's more cool in action. Sorry? Oh, yeah. Here's my mic holder. And let me just open up. This is the repo actually that you saw in the browser. Let me just open up a simple flake. And let me open up the terminal. Can you see everything, or perhaps? So as you can see, we have some inputs. This is the official repo of Nix packages. There are paths here. Those inputs are here after resolution. And those are the things we care about the most, packages and dev shells. And let me show you the dev shells first. We make, with this function, we make a simple, very simple dev shell. We list some packages that we want to have. A shell hook is basically just a bash script that runs when we enter the shell, and some environment variables. So right now in the terminal, let me just delete that. If I enter the shell, if I actually first try to print out the editor variable, it's neovim. And if I try to use node, I don't have node here. But right after I type nix develop, Nix will create a new environment for us, enter a new shell. This is actually pretty not good looking shell, but this can be fixed. And now, if I type node, I suddenly have node, and it's the exact same version I specified here. And if I try to echo the editor variable, it's suddenly helix, ajax, which we specified here. And if I leave this shell, try to use node again, I don't have it. So this is great for developing the project with the exact environment that you want to use, with the exact packages and dependency you want to have. And it's the same stuff for packages, it's just that it builds something for us. So in this environment, it doesn't enter this environment. So we use here like a almost built-in function to build npm package. So this just bundles some basic front-end, I think, from the source. So if I run nix build with the name sample app, it will give us actually a symlink to a magical place called the Nix store, but when we browse this result directory, it will have all of the things that we specified here that we want to have in the build and in the public directory. So everything that we need to build our application. So that's cool. Let's move on with the presentation. Oh, just two? Oh, okay. Can we have four? Okay. I'll try to speed up. So this was Nix. I'm gonna go with a. This is like a fun fact which surprised me. We don't have time for this actually, but it's a fun fact that the Nix packages repository, the official repository, is way, way bigger than any other package manager repository. This is some small text here, but this big red arrow points to the unstable version of Nix packages official repository. All of the dots below are basically different versions of Nix packages repository. And this circle, red circle right here, points to a homebrew repository. So, and this is this graph actually I didn't say. This graph shows number of packages basically. So the higher you are, and more on the right, the more packages. So the difference is massive, and that's exactly how we deployed Kubernetes, because Nix OS uses those concepts of Nix, creates the declare environment, but for the whole operating system. And that's why we could do this. We could enable K3s just by typing this line, and basically K3s developers packaged all of those things from documentation into a Nix service, or Nix community maybe did that, I don't know, but package it into Nix service, and so we can just use it like that. So how do we actually deploy something? We had 2 minutes, goddamn. So how do we deploy something? So we're going to use a library called kubenix, which lets us manage Kubernetes also with Nix. We're going to use Nix for everything. So let me just show you. Let me show you action. Let me show you some action. We're going to enter the root flake.nix. This is a bigger one. But in the inputs, like I said, you import some stuff. We import the kubenix. And this is a package called kubenix. And this is basically most of this stuff is some template code that you can copy on GitHub. But what this lets us to do is if we just run a magical command, you don't have to know what this command does. This is actually kubectl for anyone that knows Kubernetes. This shows us what is running on our server, and let's add something by just typing it into our project flake.nix. We're going to add something to our server, and we don't have any LSP in here. I hope I get that correctly. But I guess we're just going to deploy some basic Docker image, spec, right? Spec. This stuff usually lives in the internet, and you copy it from there. Containers, main. That's a name, I think. Okay, we're gonna go with one of my very advanced application, which is just a text server. We're not gonna use it. We're just gonna see that I can run now Nix run, which, oh shit, my bad, I didn't say that. And right now, kubenix, the Nix run basically runs the main executable of this package that kubenix exposes to us. And this basically, kubenix evaluates the Nix code, generates all of the stuff that we didn't have to write. We just wrote this one line. And when I accept this, it will sync the Kubernetes cluster that we deployed on the server with the code that we wrote in Nix. So right after this finishes, if we check out what is running on our server, it will be three things, which are pods, but three things. And this is exactly what we declared here. If we remove it, it will be pruned and removed from the server. So that's exactly how we deployed the blog that you saw. We built the blog app, which is a ban frontend with Nix. We then made from this package, can you see my cursor? We made a Docker image from it, and we actually referenced this Docker image. Actually, we didn't do that, but we did, yes. Reference this blog image name and tag in the code that describes our Kubernetes cluster. So when we just make some changes into our source code of our blog website and do git push and have some smart GitHub action that just builds this infrastructure code, it will build all of the things by a chain effect. I hope that was not too much information in in one go. So this is a summary. So we basically what we did. Okay. We used Nix for everything. We deployed Kubernetes with Nix. We built our application with Nix. We packaged it in the Docker image, connected to Kubernetes with kubenix, and deployed the app with kubenix by declaring the stuff in Nix in kubenix. So you can do basically everything in Nix, and you don't really care much about Kubernetes, I guess, if you don't want to. So that was it. Like we said earlier, we have made a blog for this. And on this website, there's actually a link to repositories, so you can browse to the source code as well. And that's it. Thank you.
I love that. I absolutely love that. Do you know why Nix configs are so scary and convoluted? Because Nix was created in 2003 as someone's master thesis, basically. It was a guy from a Dutch university. That's crazy.
And actually, I am reading this paper right now, this original paper.
Lovely. All right. Do we have any questions? We have questions right there. Okay, I'm running.
Thanks for presentation. I never heard about the Nix before, so thank you. I will deep dive in that topic. But I have a short question. Why is that better than Coolify?
Well, I'm not, Coolify is like an open source Vercel or something, right? So I'm not exactly sure what Coolify offers, but I guess you have some UI and you can deploy there, something like that.
Yeah, it's like Firebase, Supabase essentially.
Well,
Way.
I think the main thing that is better than Coolify is the Kubernetes itself, because you can do like if you, for example, can you deploy ClickHouse to Coolify? Okay, so you can deploy anything you can build open source. Okay. So any like cutting edge technology, unstable anything, right? Not just what's supported. Okay, so that's great. I actually don't really know what to say. Do you have an idea? Oh, and what's the? I mean, not just Nix, but I guess Kubernetes by itself could be much better because there are many extensions to Kubernetes and many operators that so you can do very cool stuff with Kubernetes.
First, we're going to have a round of applause for those fantastic people. It was amazing. Thank you.
Warsaw.